then you'll get into the full view, full screen mode, and that'll make it easier to view all the screens and things. We'll leave about 10 minutes at the end today to ask questions. So if you have a question, the audio will be turned off through the webinar just to make it easier to present and things. But if you have questions during the webinar, feel free to type them into the question box. And then my colleague Amber, who's sitting with me today, will be looking at those questions, and I'll ask her for questions from the group at the end of the webinar. All right, let's get started. So first off, there's this question of why would you want to put your R model on the web? Like, what's the purpose of it? And the reason is that it's sort of a force multiplier for models that have been built. You think about the amount of time that it takes to build a model in R or any other package, really. There's often months or even years of people's lives that are spent among data scientists putting these things together, but they're often only accessible to the people who originally built them. You're dealing with an unfamiliar interface for people who aren't modelers, and if you're asking somebody to try out a model in this format, they're probably unlikely to do it unless they know you really well and think, I'm really going to get some value from learning this sort of unfamiliar application. Whereas if you have an application, an analytics application that's online, there's a huge advantage in the sense that now thousands, hundreds of thousands, even millions of strangers can access the simulation or the application and share it with their colleagues. They can see it, they can learn from it, and they can interact with it. So there's a huge increase in the number of people that can learn from and benefit from the analytics work that's been done. What we're going to be using today is this platform called Forio Epicenter. It's our third generation platform, but the first generation platform that Forio's had that supports R and some other scientific and technical computing languages like Python and Julia. And the platform is used for hosting server-side models. It's for creating interactive interfaces and for sharing insights. On the web, we're going to be focusing on the web today, but can also share things on mobile. And because it's using general purpose technical computing languages like R, you can do a variety of things with it. You can use it for simulations, you can use it for statistical analyses, you can do machine learning, optimizations, a variety of things with the platform for hosting these analytics applications online. This is a sample of the types of languages that are supported on Epicenter. And so these languages are hosted on the server, and you would upload for today an R model onto the server, but we also support things like Julia, which is a newish language, it's 3 or 4 years old at this point, for doing, it's sort of MATLAB-like, I guess. Python, of course, we also can host Java and Lua and some commercial packages like BenSim on the server as well, including things like, and then also we have our own languages, SimLang, and some Excel as well. And what I want to do today to start off is to show some examples of applications that have been built with a variety of languages, just to give you a flavor for how these things work and what they look like when they're finished. And then we're going to go through building something together and kind of take a look at that. So let me start with that. And what I'd like to do is just start off with this investment portfolio tool. And this is a tool that is for illustrating how investments work over time and how you need to find portfolios of investments that are created from markets that are negatively correlated. So that's kind of the basics of investment portfolio theory from Markowitz. And here we can see, for example, a table where we have emerging markets and global bonds that are negatively correlated. And our goal in this little tool is to explore, this is sort of a one-page application, but in this tool is to get a return of at least $120 while minimizing our chances of losing $5. So right now we have a return that's lower than that, and we have a very low chance of loss. And the reason for that, as you can see in the bottom, is that we have everything in cash. So what we want to do then is explore, say, increasing our portion of our portfolio in emerging markets and in global bonds, and then reducing the amount in cash. Okay, so now we have sort of an interesting split, and we've achieved our outcome, but we have a much higher chance of loss than before. Let me see what I can do to dial that down, and what I can do here is reduce that. And what's actually happening behind the scenes here, there's a Monte Carlo run of 1,000 Monte Carlo runs that are generating this result here over 5 years, and I can see my average return and chances of loss here, and I can sort of experiment with different values. You can see now I'm actually getting a higher chance of loss, but I'm still achieving my outcome here over time. And so if I'm happy with that result, I could put in my name and submit it. And this is sort of this is my result here actually. This is sort of a game in the sense of it keeps track of the last 10 players and shows a score. And so that's how this one works. And what's happening behind the scenes here is there's a model that's running on the server, and there's this interface that's pulling data back and forth across the server for running these results and displaying it in this interface. So let me show you another example. This is on optimization. This is around route optimization, or it's classically called the traveling salesman problem. And what I can do is look at a route, and this is the city of San Francisco where we are right now, and calculate an optimized route. And what you can see here is there's been some time savings here that as a consequence of finding the optimized route versus my sort of arbitrary route, I've saved half my time and I've reduced my distance by over half in terms of distance traveled. So that's a pretty good outcome. What's interesting about this one, I think, is that it's showing how you can build epicenter applications that connect to other data sources and APIs. So the city of San Francisco, for example, provides an API that lists all the 50,000 or so businesses in the city, as well as their locations. And we're pulling that to get some arbitrary locations here. And we're using, what's probably obvious to many of you, Google Maps for the mapping tools here. And also what's behind the scenes happening is that this route optimizer is not optimizing based on distance, but instead is basing it on duration. And so what it's using actually is an API for traffic data, real-time traffic data, to look up what the distances are between, or rather the time is between various points, and using that for the optimization. So this is actually using, right now it's 11:11 a.m. in San Francisco, and so this is the optimum route right now. And that route might change, at say rush hour at 5 p.m. or something like that later in the day. And there's also some opportunities in here for exploring personalized travel and things like that. We can put in, other locations and things so that you can actually build something. And this is part of the interaction that's occurring where non-experts can access the tool. Here's another example of a tool that was built on Epicenter that explores HIV and AIDS in Vietnam. And one of the obvious things in terms of providing a model this way is access to, in this case, clinicians who want to understand how to allocate resources. This model works in both English and Vietnamese. And of course, for the clinicians to benefit from the insights from the model, it needs to be in a language they understand. And it also is set up so that it can represent different provinces within Vietnam. I'll go into the Haiphong right now as an example. And what this one does is a different style of simulation. What it's doing is looking at new cases, forecasting into the future, and I'm allowed to do some things like make some investments or make some decisions around what I want to focus on. If I focus on, for example, as I'm doing here broadly on prevention, I can create a scenario. And I can then compare my prevention scenario against my baseline and look at sort of an expanded graph of this and get data out of it, and also compare results across multiple scenarios if I want to. So what this is doing is making this tool a lot more accessible to a variety of people, and it's also shareable, and people can save results as well. So if they've created sort of an interesting run and they want to save it for themselves to look at later, they can do so if they have an account on here. And they can also share it with their colleagues. Okay. A fourth example is using machine learning, using random forests. And what we can do here is look at recommendations from Yelp in this case. Let me refresh this because I think I had this sitting here for a while. And what I can do, for example, is look at a restaurant called First Watch. And if I like that restaurant, what I'm trying to do with this is to discover restaurants that are like First Watch that I might want to go to that I've never been to before. So it's not about finding the best within a category, but it's more about saying, well, this is the kind of thing I like, and what are other things that are like it that I might also like that I can discover. And so if I click here and say, well, I like First Watch, maybe I'm also interested in Joe's Diner. And I can click on Joe's Diner here and then see something about Joe's Diner and how closely it matches with First Watch. And I'm below here building up sort of a list of discovered restaurants that I can share on Facebook or tweet about or email to myself if I want to have kind of a list available. And again, using a combination of data APIs for pulling data and an analytics engine, in this case, running on Python. Okay, so that's what I wanted to share as far as examples. We're actually going to build an example today, and I wanted to illustrate how that works. I guess what I'll do is start off by kind of talking about where we're getting the data for this example. So what we're using today is Google Trends. I'm sure many of you have used this before. It's a fun resource to explore different terms. Here we see the term data science, and I was pleased to see that still ramping up over time. With something, but what we can do is put in other terms here. So for example, let me put in a term like swimming. And here you can see some results for the term swimming over time. And perhaps not surprisingly, what you see is that there's a sort of a seasonal pattern to the term swimming that exists in Google Trends, right? So that's probably not very surprising because you figure people swim in the summertime and they swim less in the winter, and you kind of see that emerging from here. And what we've done for today is we've loaded 10 different data sets into a time series. And by the way, what's interesting is when we're putting this together, you can see here that Google Trends is doing some kind of smoothing or reducing the data points. When you download these data, which you can see here, you can download it as a CSV, or there's other ways of getting data out of this. There's some API options for doing it as well. But when you actually look at it here, this is by the way, this is what we're going to build today. We're going to look at how this was constructed and show some examples. Let me refresh this. Make sure that we're starting from the beginning here. But what you can see here in the loaded data, there's actually a lot more detail, right? And one of the things that I think is interesting is these points along here. It's like, one of the things I'm trying to figure out is why is it that there's these periodic blips in swimming every few years here. And probably some of you know the answer to this, but it took me a minute to figure it out, which is that there's the Olympics. So the Olympics are driving it. Amber, I think, knew the answer to that. He was sitting across from me. He's smiling over here. And yeah, so that's sort of interesting, and that's sort of lost in the original data. And it also says something about decomposition. So one of the things we're looking at right now is the seasonal decomposition of time. And that's what part of what this tool is doing. And you can see here that what we've done is we've taken this data set and we've now decomposed it into seasonality, trend, and then of course the residuals, right? And what's nice about this, you can sort of see what happens here. If you look at it's divided into 52 week segments, and you can kind of see what happens from year to year here, that it peaks in the summer, it looks like August or so, and then it goes down in December and January, and then right after January, it kind of kicks up again. It must be people who are, exercising after the end of the holidays or something like that. I see some examples of that in here. And then sort of the reverse of it, for other data sets, we can look at this as well, and we can, decompose this for other sets here. So we see the original data here for snowboarding. You see snowboarding as a term, at least, is becoming less popular over time, which is interesting. But the seasonality effect in it, you can see, is peaking instead of dropping in the winter, right? So here in December and January, it's when it's at its peak, and then it's very low in the summertime, not surprising. And that's the pattern that's following. But the trend is kind of going down over time. And there's other kinds of patterns here too. If we look at Lego, we see an interesting pattern where there's a peak before the winter holidays, and what we see in general, that this is kind of trending up over time. Some data, by the way, some patterns don't seem to follow the seasonal pattern, of course, and there's a lot of variation among data. And one of the things we can see here is the term Facebook, for example, is going up. There's some increase that happened here. Maybe that was the IPO, I don't know. And then it's starting to drop off a little bit. And there's sort of a similar pattern, interestingly, with Twitter. There's a nice regular pattern here for allergies. I'm just going to skip around a little bit, which is what you can see here is that it's really seasonal, and it has kind of a couple peaks in it. There's a spring peak for allergies, and there's a fall peak for allergies, and then it drops off again, and it's trending kind of level over time. So this is a really good one for doing an ARIMA style analysis. All of these are actually reasonable for that, depending on how you set it up. But this is sort of a nice pattern here. And then, some interesting ones too, kind of like the swimming one I showed before. We have election as a term. And what you can see here, this is 2004. You have the presidential election being a peak. Then you have midterm elections as a smaller peak, presidential, midterm, presidential. Now, because I set my frequency for this analysis up at 52 weeks, I'm not really doing this correctly, right? So it exposes a little bit of the problem with analyzing these kinds of data, that we're not really getting, what I would really need to do this properly is look at an 8-year segment, right? So 8 years would be the right level of seasonality for this particular data set. I'm not doing it, but I am seeing some peaks here, and the consequence of that is I'm getting a lot of residuals. It sort of indicates that I'm doing something wrong here. Last one I wanted to share, and partly because I don't know the reason for it, is this paleo example. So paleo is trending up, not surprisingly, as a term, right, for the paleo diet, presumably. But what's in the seasonality bit, what you see is there's sort of 3 peaks. There's a peak right after the holidays again. Again, probably related to recovering from the holidays. Then there's one in the spring, it looks like, and one in the late summer or early fall, something like that. So I don't know the reason for that. If any of you have an idea behind that, and you want to propose one, I'd be interested in hearing maybe at the end of the webinar today. But this is kind of what we're building. And then in addition, what we want to do, actually, I want to use a different data set. Let me go to, let's just use the swimming data set as the first one here. I'm going to decompose that as a starting point. And then what I'm going to do is switch to the forecasting tab. And what I can do here is start to do some things with forecasting, right? So what I want to do is provide training data for training my data set, and then also a point where I can do forecasting. And then I can use the data that I have for after the forecast for testing my data. And I can extend this if I want to too, and I'll go ahead and forecast this. And here you see the outcome of my forecast, which is the green line, versus the test data, which is the blue line. And you can see I did pretty well. I missed the Summer Olympics for 1 year here, but the general periodic trend is working okay. And you can see some sort of summary results over here on the right. So that's kind of how this works, and I can experiment with moving around my data set in terms of the window for training and stopping the training, and also the forecast horizon and things like that. And it's going to produce different results over time, and will change sort of the outcome. And what I can do is experiment with all these different data sets and look at different training time and different forecast times and forecast horizons, and see how well my forecasts do. Okay, so that's the idea of this. And you can see that this is much more accessible than the R code, right? So let me just show you the R model here. This is what the R model looks like. I mean, actually, this R model is a very simple model. That's one of the nice things about R, but it's much more accessible in this form online. So why are we doing this? And I think one of the things that we're trying to do is to get people who aren't data scientists, who aren't building models, to become data scientists, essentially. And what is it? Why has this term become popular? And why is the word scientist associated with data for people who are doing this kind of thing? And I think it's appropriate. And the reason is that what you're doing is you're researching data, you're making experiments, like I was just doing now, right? So you sort of experiment with different data sets, you look at what's going on, and you say, why are these peaks happening, and things like that. And then you make discoveries with the data by manipulating it in great ways. And the easier it is to do that, the more discoveries you can make. And also, the broader audience you reach with it, the more discoveries they can make on their own and retain and kind of share within a community. And there's a nice quote from Isaac Asimov, which is, the most exciting phrase to hear in science, the one that heralds new discoveries, is not eureka, but that's funny, right? And so that's kind of what we're driving at with this tool is, we see something like the paleo, for example, like, why is that bouncing around that way? And the reason for it, I don't know the answer, but there is a reason for it. And discovering it might tell us something about, about how that diet is working, or about other things that are being done with the same term, or perhaps something about the way that humans behave over seasons and things like that over the course of the year. There's a variety of things. So now what I want to do is switch gears and actually show you how to build this. And I'm going to do that in the next 30 minutes or so. Okay, what I want to do is talk to you about the levels of interface technology that can be used for Epicenter. And there's actually 5 levels that we support. And each of these are kind of built on the previous lower levels. And you can use any of these, but there's kind of a trade-off among them. So there's a UI or user interface designer tool, which is kind of a drag and drop tool. That's really easy to use. There's a level below that called Flow.js, which is uses some simple HTML and JavaScript. Epicenter, which is a lower level library, but still using JavaScript. And then you can get down into using the APIs directly if you want to. And as you go up this pyramid, essentially, things get easier to use. But the trade-off is that as you go up, you have less flexibility. And what I find for myself as somebody who does a lot of modeling and simulation work and is familiar with basic coding and things, and I think for this audience today, for you all who are listening to this as R modelers, that Flow.js is the right level. And the reason for it, there's some parallels between the way that this Flow.js level works and the way that R works. And I'm going to expose some of that today. So what we're going to be doing today for the rest of the webinar is using this Flow.js level for building this out. And what it does is it's a nice trade-off between ease of use and flexibility, which gives you a nice tool for creating clean designs, good-looking designs that can resize properly and things like that. So let's start by taking a look at our model, just so we get a sense for what's going on here. So here's our model, and like I said, one of the nice things about R is, of course, the package system. Here we're using 2 packages. We're using this forecast library. We're also using the Epicenter package, but I'm not using it right now in our studio because I don't need Epicenter to run it locally, but I do need it to run it within Epicenter directly. And then I have a bunch of data sets. I could have linked to these remotely through APIs and things, but I chose not to today because that would be another hour of webinar to explain how to do that. Then below here, what I have are some variables that I can change, like the starting year, the test year, the forecast horizon, what we've looked at already. And then I have 2 functions. I have a function for decomposing the data set, whatever data set I selected, and I have a function for making a forecast. And they're both really simple. And again, I think this is just one of the beautiful things about R is that, within a few lines, you can do some really interesting things if you're using these packages and things. And I can expose that down here if I do make forecast, and I'll run that routine, and then I can do, what's the correlation, for example, and I see a correlation come out of this. I can also look at what is my forecast data. So here's a data set that's coming out for the 52 weeks, starting at 24 and ending at 19, and I can look at my test data, which should match that, and I can see, that starts a little bit higher, but ends at roughly the same point. So I'm getting some sense for how this is working. And then I can do things here too if I want to, like I could say, well, what I want to do is change the, let's say I'm going to change the training year. So I can say, let's change that training year from 2004 to 2005, for example. There we go. And then if I do the make forecast again as a function and do the correlation again, I'll see a different correlation, a little bit lower, I think. Is that right? No, a little bit higher, actually. A little bit higher. And then I can see, other things changing, like not surprisingly, the forecast data should be different and so on, right? So that's basically how this works. And this is, again, illustrating, I think, a reason why you want to provide an interface versus just working with it directly in a tool like RStudio. Although this is a great tool, obviously, for modeling on your own and sort of experimenting with things to kind of actually build the model out. Okay, so what we want to do then is we want to get this model into Epicenter. And what I'm going to do to start that off is to go into Epicenter. Actually, what I meant to do is start from the beginning. And what you can all do too, by the way, you can get free accounts in Epicenter to try these things on your own. And at the end of the webinar, what we'll do is we'll send out the files that I'm showing today so that you can create this on your own after the webinar is over. So what I'm going to do now is go into Epicenter and log into my account. And not surprisingly, I've been in here before. I have a bunch of projects that I've built on my own, and there's a bunch of group projects as well. I'm going to skip some of that today, right now, but I just want to point out that there's different levels of access. You can have teams of people that collaborate together to create models and interfaces, and you can use the team accounts for that. The team accounts allow you to do authentication if you want to have people log in. If you want people just to access the interface without logging in, then you can use personal accounts, and those accounts are free. So here's my project area, and I have a bunch of stuff in here. As I said, I'm going to create a new project right now. I'm going to go to make my own project as a link, so I can either use an example or make my own project. And I'm going to call this my R webinar example, I guess. That's what I'm going to call it today. And what you can see here is when I typed in the name of this R webinar example, it created a project ID that is a URL essentially. So it's forio.com/app / the name of my account, which my personal account is called mbean, my name Michael Bean. And then what it's done is it's turned this into a URL-friendly link. And if I had used the capitalization, it would have put everything in lowercase. Where you can see it replaced the spaces with hyphens. If I don't like that name, I can go in there and change it if I want to. If I want to say, example 1 or something like that, I can do that as well. And then I have, for the individual accounts, I have only 2 forms of access. It can be either public or private. In the team accounts, I can also have this level called authenticated, which means that users need to log in to access it. For today, I'm going to make this public so that later on, after the webinar is over, if you want to check this out, you can do so by just going to the URL that I'm creating. And then I'm going to create a project. Now, right now, there's nothing in this project. It's empty. I'm creating it from scratch. So what I need to do is put some files in it to build this up. And I'm going to start by uploading some interface files here. And there's a few ways to do that. You can go to Actions, Add Files. You can upload files, or you can upload a zip file that contains subfiles below that, and it'll upload it and then unzip them and put them in the directory. There's also ways, by the way, of connecting it to folders on your desktop, on your computer, so that when you're dragging files in and out of those folders, it'll automatically update with the interface folder and model folders in Epicenter. But for today, what I'm going to do is just a drag and drop approach. And the way I'm going to do that is to drag in these HTML files here. And there they all are. They've just been uploaded at 11:31 a.m. So they're all in place for today. Okay, so I've got that now, and we're going to go through and I'm going to show you how all this works in a minute. And now I need to get a model in. And what I'm going to do for this is take a slightly different approach just to show alternatives here. Here I'm going to go to Add File, and I'm going to call the name of my file, which I want to keep consistent with what I called it here, which is timeseries.r with an underscore in it. So let me do that. I'm going to call timeseries.r. And then what I want to do is add in the files for it. And actually, what I'm going to do for this is, where's that? There we go. Is put in the starting one. And this one you can see has Library Epicenter at the top. That's an important piece of it. Really, the only thing you need to do to get R to work with Epicenter is to put this library message at the top, and then you can include the other libraries that you're using in your project here as well. So I'm going to copy this out and paste this in here. So now you can see here's my file just pasted in, and then save it. And now you can see it's saved. And if I go to the model directory now, there's timeseries.r in here from 11:32 a.m. and I've got my interface files. And that's really enough to get started. So now if I go to project and go to example, and what I'm going to do is I'm going to open this in a private window. And the reason I'm doing that is I want to have a clean session. I want to have a session that doesn't have other stuff. And I don't need to do that because I'm going to be going back and forth a lot today. With this, I want to use a private session. So that's how I'm going to handle that. And here you can see it's loading. And there's our data from the swimming bit. And then we can have the forecast as we showed before. And it's doing the same thing we saw a moment ago. Okay, so that's the basics for getting things started. But that's still magic in the sense of I haven't shown you the underlying code for how to build the interfaces. And I think the way to illustrate this is to use this basic example. So what I've done for today is I've created a basic example that has kind of the minimum that you need in order to communicate back and forth between a model and an interface. And what you can see here is I put in the training data start year. So I'm able to edit that number here, which was 2004 as a starting point. And I've also just left this coefficient in so I have something to look at as an outcome. And everything else I've taken out because I just want to make it really simple. And I can press forecast if I want here. And it's going to update. If I change this to 2005, presumably that coefficient will change. Yeah, so now it's changed to 94.4 as we saw in the previous example. And you can see that there's interaction occurring here. So how is this done? Let's take a look at our files for that. So we have basic here. And this is the code that you would use for creating this, and it's pretty short, really. If you look at it, it's just a few lines long. It's kind of a page worth of material for creating that basic interface. And what we're starting with, and I think this is analogous to the way that packages work in R, is a header within HTML that just loads a bunch of JavaScript libraries. And these are mostly common libraries that are used in JavaScript for doing common things. And what's nice about that is that these libraries, because they're used throughout the web and not exclusively by people who are trying to put R models up, for example, on Forio or something, is that they're constantly being updated. Right now, like a week ago or so, Microsoft introduced Internet Explorer Edge, a completely new platform with a completely different sort of not syntax, but different acceptance of, say, HTML5, let's put it that way. And what's nice is there are many people out there who are looking at that and updating these libraries, like D3, for example. D3 is a graphics library that's used by the New York Times for doing their data visualizations, and we're using that as well here. Lodash is a popular library. There's jQuery, which is a very popular library as well for simplifying things across browsers on the web. And then, of course, we have our own libraries here as well. We have Epicenter and Flow.js, and both of those are used. And I showed that stack earlier, and Epicenter relies on jQuery and some of these other libraries. Flow.js relies on Epicenter, and so we're kind of stacking these together here. And these are just libraries that we're loading in much the same way that you load libraries or packages in R. And then related to that, we have some styling to make this look nice. And you might remember from our interface earlier, we've got these nice tabs. We've got some layout things here that we're doing, and some of that is handled by the CSS. There's a library called Bootstrap that's very popular. Actually, let me just show it to you quickly. Do it here, I guess. And it provides all kinds of sort of components for doing nice things on the web. Like if you want to do a nav bar, for example, like what we're doing today, or actually I think navs is the right side. So here you can see how to do tabs, and it's very simple. It's just a little bit here, and all I did was include that library and then put in a little bit of JavaScript, and I produced a nice kind of tabbed interface that works cross-browser. And I get that kind of for free, right? I don't have to do a lot of coding to figure out how to do that. It's just given to me by Bootstrap. So you can do something like that too, and you can kind of gain from all this material that's out there on the web for building these things. So what I can see next is my body tag for HTML. And now what I'm doing is I'm using this Flow.js syntax, which includes data-f -on init. In this case, it says when you initialize this file, what should I do? And then what I want to do is I want to run this routine called make forecast. And as you may remember from my R code here, there's make forecast is a function, and what that will do is when this page loads, it'll run that function. And that's going to put in the data, the results that I want to see, and make them available to the web page for displaying it. Here's the little navigation that I was mentioning a moment ago that I got from Bootstrap. And then below here, what I want to do is have an input box. And let me just go back for a moment to remind us all what that was looking like. Here it is, right? So here's an input box that I can edit and type numbers into. And notice that it's loading with data from the model, from my R model. And it's also letting me send data back to it, right? It goes kind of two directions here. In order to do that, what I need to do is just use a standard HTML input box. But what I do is I say data-f-bind equal, and then give it the name of the variable in my R model, which in this case is start training year. So again, if I go back to my R model, you can see at the top is start training year is set to 2004, and that's what it's using here. So that's how that works. And then I have a button that allows me to interact with it by if I change this. And the way that button works is it just calls that routine again called make forecast. And it works, it says data-f-on click. So when I click the button, which is a standard HTML object, it's going to run the subroutine, and then it will update, for example, start training year here, and it'll also update this correlation variable that I have. And notice what I've done here in the R model under make forecast is I have correl, which is my correlation variable, and I'm just using this simple function that's available in R for doing that. Notice also, if you're familiar with the syntax, the double arrow, and what this does is it turns this into a global variable. So that what that means is it's available outside the function. And because I want it to be available without, outside the function, so I can access it without running the function, that's what I'm doing. So I'm in fact making all of these set up as global variables here. And that's how that works. Okay, so we have the basics there, and the next step in it is to actually link to the model. One of the things I need to do is to tell the model tell the interface what model I want to use here, and say, in this case, I'm going to say time series.r. So I'm just saying that here is the name of the model, and that's really all that you need to do in order to connect it up and to let it know that that's the model that we're using for this particular page in the interface. And by the way, this is nice too in case you want to run multiple models. One of the things I could have done is disaggregated the decomposition piece from the forecasting piece, and I could have had them as two separate models, and then I could have had that just appear here if I wanted to, and I could have multiple models and they can even interact. So we have examples, for example, of models that are from Python and R or Venson and R and so on working together here. But that's enough to get started, and that code then produces this output that we saw here a moment ago along with the forecast. So we've now shown how to update this field, do this forecast, and get this result out of it. But a key thing that we all want to do in interfaces is create graphs, right? So we want to be able to see results over time. And what I wanted to illustrate next here was that bit, like how do I get a comparison between the green line, which is my forecast, and the blue line, which is my test data over time here. So how does this chart produce? This chart is using, ultimately what it's using is something called D3, which is a great library for producing charts, but is sort of complicated. Let me show it to you here. Let's see here. There you go. So I'm just going to look up D3 here. And D3 has a lot of power. You can use, by the way, you can use D3 directly with Epicenter, but we have a way to do it simpler as well. So here's a D3, and you can do, all these data visualizations are available as a library that you can pull into it, but it can get a bit complex. So let's just find an example of something that looks simple. Let's say this population pyramid here. That's a pretty simple chart, and it looks pretty nice. If you look at the code for this, it's a little bit complicated. It's kind of a lot to do a bar chart, right? There's sort of a lot of code there for something that seems like it should be fairly simple. And granted, this is a somewhat sophisticated bar chart. I think it has some interactions in it, things like that that are cool, but it's still a lot of code for that. What Forio has, and by the way, this is an open source library. It's licensed with a license that's commercial friendly, so it's accessible in that sense. What we have done is develop a library on top of D3 that makes it more accessible, and it's called Forio Contour, and that's what we're going to be using for this. Contour doesn't have to be used with Epicenter. It can be used with other projects as well. It's just a general graphing library. But what it does is it works with D3 to make it easier to do basic graphs. And so one of the things I might want to do, for example, is create a line chart. And I can see that here in Contour. And here you can see to do a line chart, it's fairly simple. I just give it the name of a data set, and I say new contour chart, and then I indicate where I want the chart to appear, and I say, use a Cartesian plane, draw it as a line chart, and render it, and that will do it. And I can easily change that to different chart types. So if I go in here, for example, and say instead of line, I want to use a bar chart, and I run that, now did I do that right? Maybe not. All right. Well, anyway, I can create different kinds of charts out of here within Contour. So that's the basic idea. And that's what we're going to use today to generate charts that are connected up to our R model. So let's take a look at that. And well, as I showed you a moment ago, this is what we're building, right? So this is a bar chart. It has an x-axis with some values on it, showing the y-axis here as well, and we're comparing it. They have these little anchors that are on here. And we're showing a couple lines. Let's go back to our example and look at basic graph. And what we've done here, we've got a couple of things that we've added. We have, first off, a div tag that just indicates where I want the chart to appear and also the height of the chart. I can do width as well if I want to, but today I just put in height and I'll just adjust it. So all this is doing, this little tag is just saying, put the chart in this location on my web page. And so above here I said forecast versus test data as a title for it, and then I put the chart here. And then what I need to do is populate that chart with relevant stuff from Contour. And the way that that works is this is a little bit that I've added to my basic chart. So I've got test data equal new Contour, and I refer to the element ID of test data. And here you can see I refer to this as test data. And what that means is the information that appears here is going to be replaced up here in the div tag for test data. And below that, then, what I can do is refer to the variables that I want to plot. In this case, I want to plot test data and forecast data. Those are coming from my R model here. So here you can see test data as one of my variables and forecast data as the other one. And those are what I'm going to be showing. And then I just say, for test data, for that div chart, render those values. And that's it. If you do those two things, in this little bit of code, you can get this chart to come out here, and it'll look just like what I've shown here. Now, there's some cleanup that we want to do too here. Like, for example, if you remember on our forecasting example, we wanted to be able to show things in 52-week increments. I took out the anchors and things like that. So there's some fancier kind of cleanup that I've done in the styling of this, and let me just show you a little bit about that, because there's ways of extending this, right? So here's, for example, my real combination of test data and forecast data in the final version that I created. And you can see here I used a max value of 100 for the y-axis. I've also said I want tick values to occur every 52 weeks. So I prefer that so I can see that it's, what's happening from year to year. I also removed the marker by saying marker enable equal false on the line, and that removes that. All that information about how to do that, by the way, is documented in Contour. So if you go to Contour and go to documentation up here, you'll see details about how, for example, to set up tick marks and things like that on the x-axis and elsewhere. So there's a lot of it. There's extensive documentation available about how to do this, and it's a pretty friendly library. And again, it's a free library to use with Contour, even with other projects. Okay, to wrap up today, I just wanted to talk a little bit about the difference between what we're doing with an application like this that's online and what you're probably used to doing when you're building an R model, right? And what I want to point out here is that building an online application is more like writing software than writing a model. And there's sort of different standards that you're held to when you're producing something online that lots of people are accessing. And in particular, what you need to do is you need to QA your analytic application. And this probably seems obvious, but there's some subtleties with this that are that need to kind of get built into your model and sometimes to your user interface to deal with that. So what you really need to do is to control what users are doing and to report problems and to fix user errors that might occur when they're running it, right? And you can do that in two places. You can do that in the user interface, in the HTML code, or you can do that in the model, all right? So let's take a look at what I mean by that in terms of examples here. Let's go back first off and look at the R model that we created before. Actually, let me show this in R here. So I have the start model, and this is what I would say is kind of a standard approach that a lone modeler would use to create a model. And it's the reason that this works is because a lone modeler kind of knows the limits of that model and what should work and what shouldn't. It knows, for example, that your test data shouldn't start before your training data, right? Your test data always needs to be later because you're training on old data and then testing on the, more recent data generally, right? Like that's how it always works. But in a user interface, let me go back to what I had created before here. Users can make errors. They can do things that aren't reasonable. So like, for example, what I could do here is I could dial this back. I could say my training data starts in 2009, but I want my forecast to start in, let's say 2007. That's illogical. And if I do that, it creates a problem. It won't work, right? And and if I show that, for example, in R here, I can do the same thing where I say, let's just make this simple here. If I say that my test year starts at the same year as my training year, I'll put that down here. Say test year is 2004, and then do make forecast down here. I get an error, right? Start cannot be after end. Of course, that's true. So what you need to do is to set up your model to control user behavior so that mistakes don't happen, and that it's kind of robust against a range of actions that users might take who may be unfamiliar with the details of how the model works. And that's sort of an important piece to building an analytics application. And the way that we're doing that today here is by using this time series example here. This is sort of the finished example, and we're adding a little bit of code to control for that. And so what we've done is we've added forecast horizon, saying that the minimum of the forecast horizon has to be 2, right? So if forecast horizon is less than 2, then it's going to show 2 here. And we're also saying that the start test year needs to be at least 3 years ahead, really in the end it's really 2 years, but 3 years ahead of the training year, so that we have at least 2 years of training data that we can use for the forecast, because if we don't have that, then the forecast method isn't going to work. And then lastly, what we also need to do is ensure that we have enough data where the test data and the forecast data are the same to do correlations. If we don't have that, then we just say that there's no correlation available. So let's take that example and upload it to our final version here. I'm going to close this off. And I'll go back to the model here, and then go to my UI, and I'll upload time series R. This is the updated version of this. Okay, so it's 11:50, which is right on time. That's good. And now show what is the final version here in a new window. And I'm like, now I've cleared the session out so that we can see that. Okay, there's my data. I'm going to forecast now, and there's my result. Now look, if I do something like, sort of nonsensical, like this, if I say my, let's move it back this way. This all should work, but and if I do a forecast now, what you'll notice is it's adjusted it. So it's kind of handled that for me by changing the forecast year and moving it forward, so it's in ahead of my training year. And if I start to do things where, for example, I want to do a forecast of, say, 156, so 3 years out or 156 weeks out, that go beyond the test data that I have available starting in year 2014, it'll do that. But notice over here on the right, it no longer attempts to show me the sort of the summary statistics on my result. You can see it started off a little bit in doing a match, but then for the later rounds, it didn't do that. All right, well, that's what I wanted to cover for the day. Like I said, there's a lot of things that you can do with Epicenter. It's a sophisticated platform that can connect to third-party services. You can store data in a database and pull up things in terms of multiple sessions. You can have multiplayer versions, which we didn't explore today. It supports multiple languages. If you want to try this on your own after we're done today, go to forio.com/epicenter, and you'll be able to experiment with building your own model. And like I said, we're going to be sending out the files that we used today at the end of the webinar. But we do have a few minutes left for some questions. Amber, if anybody has any questions that have accumulated while I've been talking.
Yeah, just a couple. John wanted to know which versions of Python we're supporting.
Yeah, okay, so John wants to know what versions of Python we're supporting. So for this alternative that that we have instead of R for running this. And we're supporting 2 different versions of Python. We support, I think it's 2.7. That's the common 2.0 version, right? Like whatever the latest 2.0, the 2-point version is, we support, as well as the 3-point version. And they're being updated frequently, but both of those I know kind of run in separate threads. And the way that the platform works overall is we support something called workers, and those workers all have different languages inside of them. So you can specify what language you want to use from the worker, and I think that's documented. I'm not a super expert on that topic, but let me just check this here. Let's see here. If you go to the documentation, if you click on these things that are books up here, and then you go to writing your model, and you go to Python, think somewhere in here it talks about the, yeah, here we go. So it says Epicenter uses 2.7.6 by default, and you can use 3.4 instead by including a configuration file. And the way you do that is specified here. So here's how you change the configuration file to use 3.4 instead of the default 2.7.6. All right, Amber, another question.
Martin says, I'm assuming R is running on your server, so the only question that's coming to mind is how to load non-standard modules, examples such as Fire or install.
Yeah, so the question is, how do you load non-standard packages on our server? Well, first off, all the packages that are available in CRAN, and probably most of you know CRAN if you're at this webinar, but this is what's referred to as the Comprehensive R Archive Network. I think that's the name of it. It's taking a minute to load here for some reason. But that's what's, that has several thousand packages in it, and all of those are available directly within Epicenter. All you have to do is load from the library. If you want to load other packages, and then what you need to do is just put them in the directory along with your model files. And so you can even have within your model directory on the in there is have subdirectories and things like that for loading it. And they don't have to be in a subdirectory, by the way, but they can be, and that's kind of sometimes a nice way to organize it. So here, if I go to model and I go to actions, I can create folder, and then I can here, have my libraries or something like that, and then put them in there, and then just keep adding stuff, then put those files inside of there, and then reference them appropriately. All right, Amber, another question.
Okay, he's asking, in what ways is Epicenter different from Shiny?
Yeah, that's a good question. I'm not super familiar with all the details of Shiny, so I don't want to overstep bounds in terms of what Shiny is. But first off, Shiny as a project is an open source project for hosting models online. I think, and one of the things that's different about Shiny by itself is that Shiny you can load on your own server kind of independently and then run things. What Epicenter provides beyond that, what Epicenter provides is hosting. I believe that the RStudio folks provide some hosting for Shiny in some packages, but and again, I'm a little bit fuzzy on all the details about things that Shiny does. But first off, there's a difference in approach, which you probably have experienced today, in the sense that what we're really focused on is having people work in R and then work on using the modeling technology, or excuse me, the interface technology of HTML to build the interface versus do it through R. And that's partly because we're supporting a bunch of different languages, but really the main reason is because we think that the best way to build an interface is to use sort of this vast library of interface technology that's available online. And then the other thing that Epicenter handles really well are things like managing groups and subscriptions. It's really built to be a commercial package. Let me show you a little bit about how that works here. Let me just I showed you that Vietnam HIV example before. So this is a project. And in this project, you can see, first off, there's a dev account or a test account that can be pushed then to production. So this is a production account. And in here, there's a series of groups. And these are groups that are who have access to running this in authentication, right? So that they're logging in and accessing it. You can see, like, here's a group that in November of 2014, there are 21 users, and we can expire those groups if we want. We can say they only have access for a year or a week or a month or whatever you want. Or you limit for the group the number of runs that they can do. And then within each group, there's a series of users, of course, and you can do control for those users as well. And what this allows you to do is all kinds of interesting things. So you can, obviously, you can control subscriptions, and you can charge for those subscriptions if you want to in a very easy way. But you can also do some interesting things with multiplayer. One of the things that our platform is used extensively for is for creating multiplayer, like business games and things like that. So you can have things where people collaborate online. Because they're logged in, they're sort of recognizing each other and stuff, and that's all handled automatically. There's also things that the platform can do in terms of managing single sign-on if you're using it in an enterprise, and it's designed to be an enterprise-based application. So, and again, I don't know if those are necessarily all unique against Shiny, but there's approaches that we're taking in order to really make Epicenter an enterprise application. The last thing I want to illustrate with this is within a within a team, here at MSH team, you can have team members. And this is an interesting way to collaborate to create high production value applications. Like some of the examples I was showing you earlier would qualify as this. And what I mean by that is that often you have teams of people who are collaborating. Some of them are data scientists, some of them are front-end designers, some of them might be project managers, some of them might be end users or clients. There might be QA in there. And so if there's a collaboration, there's a bunch of people that come together to build something, and they all want to have access to it before it's sort of published. And you don't necessarily need this if you're a lone developer, but this can be really useful if you have a team that's coming together to work on stuff. So you can invite people to the team to create things and collaborate together. All right, probably one last question, Amber, if there's anything left. Okay, I guess that's it for today. That's great. And like I said, what we'll be doing after the webinar is sending out files that I showed today. And what we'll send are files in 2 folders. There'll be a folder that's called model and a folder that is called interface. And what you do is just take the file, the R model that's in model, and put it in this folder, and then put the interface files in here, and you should have a working project. So you'll have something to start with and something to experiment with and edit to create your own interface. Thank you very much. Bye-bye.